The future of renewable energy is not just about reducing carbon emissions, it's about reimagining how we power the world. As global energy demands increase, the focus is shifting towards innovative technologies that can harness the power of nature in more efficient and sustainable ways. Solar and wind energy, once considered supplementary, are now at the forefront of energy generation. Advancements in solar technology, like perovskite solar cells, promise to capture sunlight more efficiently, even in low-light conditions, while floating solar farms are emerging as a space-saving solution on bodies of water. Wind energy is seeing a transformation with the development of airborne wind turbines and vertical-axis wind turbines, designed to generate electricity even in urban environments. But innovation doesn't stop at wind and solar. The ocean, with its powerful tides and waves, holds immense potential. Tidal and wave energy technologies are still in their infancy, but they offer a reliable source of power for coastal communities. Geothermal energy, long overlooked, is making a comeback with enhanced geothermal systems, EGS, that can tap into heat miles beneath the Earth's surface, providing a consistent and carbon-free energy source. Energy storage is also playing a critical role in the future of renewables. Breakthroughs in battery technology, particularly in solid-state batteries, are set to revolutionize how we store and use energy. These batteries promise longer life, faster charging, and enhanced safety, making renewable energy more reliable. Hydrogen, often dubbed the fuel of the future, is being explored as a clean energy source, with advancements in green hydrogen production, using renewable energy to split water into hydrogen and oxygen, offering the possibility of zero-emission fuel for transportation and industries. As we move forward, decentralization of energy systems is becoming more common. Microgrids, which allow communities to generate and manage their own power, are emerging as a solution for areas with unreliable energy infrastructure. These grids can operate independently or connect to larger networks, making energy distribution more resilient to disruptions. Emerging trends like artificial intelligence and blockchain are also poised to transform how we produce and consume energy. AI can optimize energy use by predicting demand patterns and enhancing grid stability, while blockchain technology promises to enable peer-to-peer energy trading, where individuals can buy and sell surplus energy directly. The future of renewable energy is bright, driven by innovation and a growing understanding of our planet's limitations. These emerging technologies and trends aren't just changing how we power our lives, they are shaping a more sustainable and equitable future for generations to come. As we look deeper into the future of renewable energy, one of the most significant shifts we are witnessing is the global transition towards a decentralized energy system. This move empowers individuals and communities to generate their own electricity, whether through rooftop solar panels or community wind farms. These decentralized systems, often referred to as microgrids, provide a more resilient and adaptable energy infrastructure. In regions where natural disasters or political instability disrupt traditional energy grids, these self-sustaining systems can continue to provide power, making energy access more democratic and reliable. Alongside decentralization, smart grid technology is revolutionizing the way energy is distributed and managed. Traditional energy grids were designed to distribute power in one direction, from large power plants to consumers. However, with the rise of renewable energy sources, power generation is becoming more distributed, and smart grids allow for a two-way exchange of electricity. This means homes and businesses can not only consume electricity, but also produce and sell it back to the grid. Advanced sensors and AI-driven analytics enable real-time monitoring and adjustment of energy flows, ensuring that power is distributed more efficiently and reducing the risk of outages. In terms of transportation, renewable energy is also reshaping the landscape, with electric vehicles, EVs, becoming more prominent. However, it's not just about switching to EVs, it's about how we power them. Solar-powered charging stations and advancements in wireless charging technology for vehicles are paving the way for cleaner, more convenient ways to refuel. As battery technology continues to evolve, we are likely to see longer ranges, faster charging times, and lower costs for EVs, making them accessible to a broader population. In the realm of industrial applications, renewable energy is making waves in sectors that were once heavily reliant on fossil fuels. Steel, cement, and chemical industries, often labeled as hard to decarbonize, are now exploring the use of green hydrogen and other renewable energy sources to drastically reduce their carbon footprints. These changes are not just incremental, they are foundational shifts that have the potential to transform how we build, manufacture, and sustain our economies. Bioenergy is another area where innovation is driving progress. Second and third generation biofuels, which are derived from non-food crops and waste materials, are emerging as sustainable alternatives to traditional fossil fuels. Unlike earlier biofuels, which competed with food production, these advanced biofuels do not put additional pressure on land use. Instead, they make use of agricultural waste, algae, and even captured carbon dioxide, turning what would be pollutants into clean energy sources. On a broader scale, international cooperation and policy shifts are creating an environment that nurtures the growth of renewable energy. Global agreements, such as the Paris Agreement, and national commitments to net zero emissions are driving investment in clean energy research and development. Governments are offering incentives, subsidies, and policy frameworks that encourage the adoption of renewable energy technologies. As renewable energy becomes more economically viable, the private sector is stepping in with substantial investments, recognizing the long-term financial and environmental benefits of clean energy. One of the most exciting areas of innovation is the exploration of fusion energy. Unlike nuclear fission, which splits atoms and generates radioactive waste, fusion seeks to replicate the process that powers the sun, fusing atoms together to release energy. While fusion energy is still in the experimental phase, successful breakthroughs could provide virtually limitless, clean energy, transforming the global energy landscape. As these technologies and trends converge, we are moving towards a future where renewable energy is not only an alternative, but the primary source of power for the world. This transition will not be without challenges. Issues like energy storage, grid integration, and the need for rare materials in some renewable technologies remain. However, the pace of innovation and the collective global effort to address climate change give hope that these challenges will be overcome. The future of renewable energy is about more than just switching energy sources. It's about creating a sustainable, equitable, and resilient energy ecosystem. One that prioritizes both people and the planet, ensuring that the way we power our world contributes to a brighter, cleaner future for all. As the journey towards renewable energy continues, the possibilities are limitless, and the impact will be felt for generations to come.